Welcome back to Homework Up with Miss Gore. Today we're going to be talking about our Unit 9, Day 1 homework, solving quadratics by factoring. So remember that the most important part when we are solving our quadratic equation by factoring is to make sure that our equation is equal to 0. Since it's equal to 0, I'm going to factor my equation. I'm first going to look for a GCF. I notice that there is not a GCF. So I am now looking for numbers that multiply to 12 but add to -4. So when I think about those combinations, I'm thinking that -6 and +2 will multiply to -12 and add to -4. Once I have my two factors, I'm going to break them up by setting them both equal to 0 and solving both of my equations. My solutions then will be x equals 6 or x equals -2, giving me the solutions or the roots to my equation. Number two, I'm noticing that I have a GCF of 3x minus 1. So I'm going to factor out that GCF of 3x minus 1, leaving me with an x plus 5 as my other factor. Now that I have two things multiplied to be 0, I'm going to set them both equal to 0. I'm going to solve both of my equations. Now when I solve this one here, I do end up with a fraction. I get x equals 1/3. Over here, just subtracting 5, I get x equals -5. Number 3. Now number 3, notice, is not equal to 0. So I need to take this term here and I need to add it to both sides. So I have x squared plus 5x plus 6 equals 0. I am now going to factor it. And when I'm factoring it, I'm thinking of numbers that multiply to 6 but add to 5. So I'm going to say that that is 3 and 2. Again, set them both equal to 0. This is a very important step here that you understand the zero product rule. My answers are -3 or -2. Number 4. Number 4, again, I have it equal to 0. That's wonderful. I'm now going to factor this. So this is the difference of two perfect squares. So I know that when I factor this, I'm going to take the square root of each one of my pieces, giving me x minus 7 times x plus 7. I then set them both equal to 0, and my answers are plus or minus 7. Skipping down, question 5. Question 5, now notice that this one has 4 terms to it. So this might be an instance where you want to really go back to our box method. So I'm going to use my box method. I have x to the 3rd, I have 2x squared, I have -25x, and a -50. I am now going to factor out my GCFs in every row and column. So I have an x squared as my GCF in my top row. I have a -25 in my bottom row. I have an x in my first column, and I have a 2 in my second column. This is now giving me x squared minus 25 times x plus 2 equals 0. Now this is not factored completely. So I'm going to take one more step and recognize that this right here is the difference of two perfect squares, giving me x minus 5 times x plus 5 still times my x plus 2 equals 0. I am now going to set all 3 of my pieces equal to 0. And instead of getting 2 possible roots, I end up with 3. I can have x equals 5, x equals -5, or x equals -2. I know that there's 3 possible roots here because this is to the power of 3. Hopefully that'll help you get started on the rest of the homework, and I will see you soon.